Okay, so we are now beginning a 2-week session on trig graphs. So this is sections 12.7 and 12.8 of the textbook, but to be honest, we're actually not going to use the textbook at all, but if you need to go and reference it, that's where you would go. We are going to start off, we're going to end up graphing all 6 trig functions: sine, cosine, tangent, cotangent, secant, and cosecant. And then we will have a quiz on graphing those 6 trig functions. Today we're just going to cover sine and cosine. If you have the printed worksheets, you can use them as we go along. All right, so some definitions, and I'm going to just keep on going. If you need to pause, make sure you pause and rewind as needed, but I'm going to try to keep the speed up so the video doesn't end up too long. So periodic functions are functions that repeat exactly in regular intervals called cycle. So there's repetition. Imagine that you can take a piece of this graph and then just copy and paste and copy and paste and copy and paste over and over again. That's a periodic function. So if I'm looking at this first graph here, I can imagine this piece from here to here, right, is what we call one period. It's one cycle. And this blue that I just highlighted, I could copy and paste this over and over and over again. So this second piece right here is just that first piece repeated. And this continues on and on. So we say that this one piece of blue here that I highlighted is called a cycle. It's one cycle. And we call that length of the cycle the period. So this is one cycle, right? And the period, right, I just abbreviate PD, is how long it is. How many units long is it? So this was from 0 to -2. So this was a length of 2, right? It's a distance, so distance is always positive. So I would say here that the period is 2. When I'm looking at this graph in red here, right, just pick a starting point and an ending point. These tops kind of my eyes gravitate towards them. So I notice that the function is repeating. This blue highlighted piece, copy and paste, copy and paste. So this is one cycle. And the period of this periodic function is how long is that cycle. So from this dot here to this dot here, what's that length? And it's about pi. So the period here is pi. So every interval of pi, the cycle is being copy and pasted and repeating. So those are periodic functions. The reason we're mentioning this is that sine and cosine and all of the 6 trig functions are periodic functions. They repeat in irregular intervals that we call cycles. The amplitude of sine and cosine functions is half of the difference between the max and the minimum values of the function. Amplitude is always positive. So amplitude represents a distance, okay? So we always say that it's positive. So this is what sine looks like here on the graph right here. This is not sine on the right-hand side. It's just a periodic function. But I'm going to use it to talk about amplitude. So if you find the highest point on the graph, here's the highest point, the max, and then find a minimum point on the graph, right? This would be a lowest point of the graph. The amplitude is half of the difference between the max and the min. So the difference between the max and the min is a total in this picture of 8. So half of that, the amplitude for this graph is 4, right? If we look at the sine function, highest point is right here. The lowest point is right here. That total distance is 2. And half of that, the amplitude, is 1. Remember, amplitude is always positive. That's one way of thinking about it. The other way that I usually think about it is I think of find that middle line where it starts to reflect itself or repeat. And then I just say, okay, from this middle line to the top, that's 4. And from this middle line to the bottom, that's 4. My amplitude is 4. Right? No matter how you think about it, just make sure you understand how to find amplitude. Okay, so now we're going to get into the sine and cosine functions. If you have your unit circle all filled out. That would be a helpful visual for you to go along with this. So find that. So if you look at your unit circle, when theta is 0, what's the sine value, right? Remember that all your, I know it's been a while, all your ordered pairs on your unit circle are cosine of theta, sine of theta. So find the angle 0, and what is the y value? 0. So I'm going to plot these points as I go along. If you don't have the worksheet, I would just watch for right now and then fill in your notes afterwards. So find pi over 4. Pi over 4 is 45 degrees. So what is sine of 45 degrees? It's root 2 over 2. Root 2 over 2 is about 0.71. All right, pi over 4 is this mark right here. You can't see where I'm pointing, but there's 0.71. Okay, now notice this graph paper. The x-axis is counting by radians, right? It's all in pi. The y-axis is 1, 2, 3, right? It's counting by ones. Okay, pi over 2, which is 90 degrees, right? What is sine at pi over 2? It's 1. So at pi over 2, I'm going to go to 1. And I'm just going to keep going around the circle, filling in these values. So at pi, my sine is 0. This is negative root 2 over 2. At 3 pi over 2, that's 270. So negative 1. 7 pi over 4 is 315. That's negative root 2 over 2. And at 2 pi, it is 0. So we made one full cycle around the unit circle. And when I connect the dots, this is what the sine function looks like, just for that one cycle. And we can keep repeating this. So imagine that I go around the circle again and continue, right? All these sine values are going to be the same because they're coterminal angles. So this would just continue on in the same way, right? And then this would continue on in the same way like this. Okay, so notice here we have a periodic function. This that I'm highlighting in yellow was our main first cycle, and then that cycle kept repeating and repeating and repeating. So looking at this, we are not going to graph, when we graph this, we're not going to graph every single point, and we're not going to use a table of values. We're going to use what we call critical points, right? There are 5 critical points, and we're looking at this first cycle here. So the 5 critical points is this first point right here, the last point of the cycle, the midpoint of the cycle, and then the 2 smaller midpoints. So the midpoint of this and the midpoint of this. So those 5 pink dots are what we call the 5 critical values. They're the 5 major points of our cycle, right? It hits our max, it hits our mins, it hits our beginning and our end and our middle. So those are the only points that we are going to plot. So this is the graph of the sine function. And then those 5 points repeat and repeat and repeat. Imagine copying and pasting, copying and pasting, copying and pasting. So if you were doing this by hand, let's talk about some of the characteristics here of the sine graph, right? Without any transformations, right, the parent function of sine, the most basic form of it, it's going to start at 0, 0. It's going to end at 2 pi. Its midpoint would be pi. And this is where you would want to start taking notes, by the way. And then the 2 smaller midpoints, okay, this would be pi over 2. At pi over 2, we're going up to 1. And then the other midpoint is 3 pi over 2. That goes down to negative 1. And those are your 5 critical points. So I'm going to connect them in a different color here. And that's your main cycle. So what's the domain of the sine function? And imagine this is copying and pasting, right? So it continues forever to the left and forever to the right. The domain is all real numbers. We're going forever left and forever right. Our range is our y values, right? How high and low are we going? We're going from -1 to 1, right? And we do hit those points, so we're going to include them. The period is how long is one cycle, right? This is one cycle. So how long is that one cycle? That's the period. It is 2 pi. And the amplitude, again, it's take the highest and lowest, that total distance, which is 2 in this case. Half of that is 1. So the amplitude is 1. This is a function. It passes the vertical line test. Notice that the inverse would not be a function, right? If I did the horizontal line test, the inverse is not a function, which is why we did all those restrictions back in the previous chapter, okay? So what you want to do is you want to memorize where these 5 critical points go for sine. So when I say sine, right, if I say sine function, you immediately should be able to say, okay, starts at 0, ends at 2 pi, the midpoint is also in the middle, and then the 2 smaller midpoints, the first one goes up, the second one goes down, and just memorizing that. Now these values are going to change, okay? So this might end up, because of the transformations, maybe we'll vertically compress it or vertically stretch it or shift it to the left or shift it to the right or up or down. But these 5 points always follow that same pattern. So one more time, right? No numbers in the picture. You should be able to say starting point, ending point, midpoint of those 2, right? So we're exactly in the middle. And then 2 smaller midpoints. The first one goes up, the second one goes down. And those are your 5 critical points of one cycle of sine. Okay, let's talk about cosine. So cosine, we could do the exact same thing. I'm not going to go through the whole chart again. I'm just going to pick out like our critical points here. So at 0, cosine is 1. So notice it's starting differently than sine did. At pi over 2, we're at 0. At pi, we're at -1. 3 pi over 2, we're at 0. And at 2 pi, we're at 1. So these are your 5 critical points of cosine. And then this would repeat and repeat and repeat, copy, paste, copy, paste, copy, paste. So it would look something like this, right? And those 5 dots are your main 5 critical points. So again, parent function for cosine, it's going to start up at 1. Right, this is the parent function. Starts up at 1. The end is going to be at 2 pi. That also is up at 1. The midpoint of cosine goes down to -1. And then the 2 smaller midpoints are on that x-axis line. And so that's your parent function, one cycle of cosine, okay? Notice that on the ends here it curves down because that's where it would be going next, right? Our maximum points are 1. Don't make it go up, right? It's a big mistake. All right, so domain here is all real numbers. The range is -1 to 1. The period is 2 pi. And the amplitude is 1. Same as sine, right? So when we say cosine, no numbers in the picture, you should say it starts up, it ends up, the midpoint would be down, and then the 2 smaller midpoints are on the x-axis, that middle line, and then that's your cycle. So I would go back and watch this quick little sketch a few times and make sure that you are able to do those 5 critical points. Because now we're going to add in all the transformations. So we're not just always going to graph the parent function that looks like this, right? That would be very boring. So we're going to add in all those transformations. So when you look at this, these letters should look familiar. Lots of these letters should look familiar, right? Let's actually start off with the H and the K. So your K value, I hope you're saying it at home, is going to be your vertical shift. This is going to move your whole graph either up or down. Your H is what you previously referred to as your horizontal shift. The reason I'm saying previously is because when you talk about it for trig functions, we don't call it a horizontal shift. We're going to call it a phase shift, and you should do the same thing. So don't say horizontal shift left pi. You're going to say phase shift left pi. Remember that this is opposite what you think it should be. So if you see x minus pi, you would say, I'm going to abbreviate PS, phase shift right pi. Okay? Your a value, right? If a is negative, then there's a reflection over the x-axis. Okay, we'll talk about that. I hope one of my examples has that. It does not. Okay, but I'll talk about it as we go through what that would look like. Your a value is also your vertical stretch or compression. So same rules as it's always been. If a is greater than 1 absolute value, it's a vertical stretch, right, by a compression of whatever, by a stretch of whatever. And if it is a value between 0 and 1, it's a vertical compression by a factor of, and then that a value. The a value cannot equal 0. And a is also your amplitude. So the absolute value of a is your amplitude. And what this is going to do is it's going to tell you like how far up and down to go. So in the parent function, the a value is, right, this invisible 1 right here in pink. But if we throw in, let's say like a 3, that's going to be your vertical stretch. So instead of going up to 1, this will go up to 3. And then it would also end at 3. And this would go down to -3, right? These dots would still be on your middle line. But now see how the whole graph is a vertical stretch, right? We vertically stretched that. Okay, and what did I miss? The b value. The b value is your horizontal stretch and compression. So again, it's opposite rules as the a. So if the b value is greater than 1, it's a horizontal compression. If the b value is between 0 and 1, horizontal stretch. But the really important thing about b is that it tells you the period. So a little formula you have to memorize. The period is 2 pi, because that's our normal cycle, right, of sine. 2 pi divided by the absolute value of b. And that will tell you how long your period is. So if we horizontally stretch something, that's going to change the length of the cycle, right? Normally it goes from 0 to 2 pi. If we horizontally stretch it, it might be from 0 to 4 pi, right? So doing this will tell you how long one cycle is. All of this, I use the word sine here, but it could also have been for cosine. So all these rules apply for cosine and for sine. All right, so now get excited. We're about to try some examples. All right, so I'm going to use this graph paper, and I provided you this graph paper. If you're able to print it, that would be amazing. It'll make your life so much easier. If you don't have printer paper and you can't print this, you can hand draw it. My suggestion is to, you can use loose leaf paper and use your horizontal lines of your loose leaf paper to be like counting 1, 2, 3, like, you know, on the y-axis. And then on the x-axis, you would just label and draw tick marks exactly where I have them for this graph paper. Okay. All right, so I'm going to walk you through how to graph these things. And I'm also going to be very specific about how I want you to graph. You need maybe like a colored pencil or a highlighter, because I'm going to be asking you to highlight your 5 critical points of your first cycle. So make sure you have that handy. All right, so our first example we're going to do is going to be y equals 3 cosine of x. Okay, and I have these kind of steps here that we're going to go through. A lot of people do find them helpful. It's up to you if you want to copy them down or not. Right, so first of all, when you see cosine right off the top of your head, you should be thinking cosine starts up, it ends up, in the midpoint it's down, and then at the 2 smaller midpoints, it's on that middle x-axis line. Okay, and that's your cosine 5 critical points right there. And that's what we're going to start off graphing. So number 1, right, following these steps, identify the amplitude, the period, and the transformation. So the amplitude is this a value out in front, absolute value, always positive. So our amplitude is 3. That's going to tell us how high up we should go. So these are going to be 3 up and 3 down from our x-axis, right? The period is default 2 pi. The only way that would change is if there was a b value. The b value would appear in this spot right here. Okay, and we'll do that in another example. And then the transformation. The transformation for this example, that 3, it's a vertical stretch by a factor of 3. Okay, number 2, graph the middle line. So the middle line is for us the x-axis, right? That's the middle line right now. You don't have to graph this. Some people find it helpful. I typically only graph that middle line if it's not the x-axis. So if there was a vertical shift up or a vertical shift down, then that middle line is going to change. So I typically won't graph that middle line unless there's a vertical shift up or down. So I'm going to actually erase that. All right, so step 3, find the start point. So our start point is this one right here when I said we started up. Now it says find start point left or right. So if there is a horizontal shift left or right, we're not going to start here at this point that we did when we drew our sketch, right? This point would be moved left or right. This one does not have a horizontal shift, so I'm going to start up at 0, 3. I'm going up to 3 because of my amplitude. Normally, cosine, look back at your parent function, it starts at 0, 1. I'm going up to 0, 3 because of the amplitude. Find the end point, okay? So if I'm starting at 0 and my period is 2 pi, my end of my 1 cycle is going to end at 2 pi. Where does cosine end? Look down here at my sketch. It ends up, right? How far up? Well, it matches your amplitude. So this is my first point. This is my second point. I'm making these nice, big, and bold. Right? These are my 5 critical points of my major cycle. I'm then going to find the midpoint. So from 0 to 2 pi, the midpoint is at pi. What happens at pi? Look down here. It's down at its lowest point that it could be, its minimum value. So that's going to be down from the middle line, down to -3. Okay, that was the end point. And we also did midpoint. Then you find the 2 smaller midpoints. So the 2 smaller midpoints are at pi over 2 and 3 pi over 2. Look down here at your parent function. What happens at those 2 smaller midpoints? We're on the middle line. In this case, the middle line is the x-axis. So these are my 5 critical points, okay? These are the 5 points I would want you to highlight. So if you have a colored pencil, a highlighter, but I want them to really stand out, and you'll notice that I do that on my homework as well. And then you're just gonna copy and paste and fill the rest of the graph paper. This is 1 cycle. Imagine taking these 5 points, copying it, moving it, and then pasting it. So just complete the pattern. Whoa. So complete the pattern. You would have a dot here, a dot here, a dot here, and a dot here. I'm taking those 5 yellow points, copying them, and pasting them down. And so I was able to fit 2 cycles onto this graph paper. All right, so my rule is highlight your 5 critical points and then copy and paste the rest of the graph paper. right? Just continue that pattern. Let's try another one. All right, next example, we're going to do y equals sine of x plus pi. Right, and we're going to follow those steps that I listed here before. So number 1, identify the amplitude, the period, and the transformation. So the amplitude is the number that's out in front right here, which is our invisible 1. So the amplitude is 1. The period, right, again, it would show up right here. You would do 2 pi divided by b, right? So just 2 pi in this case. And then transformation, what's happening here? This is our phase shift left pi units, okay? And then I'm thinking, okay, sine. What does sine do, right? No numbers, what does sine do? Sine starts here, has an ending point, its midpoint is on that middle line, then it goes up, then it goes down, right? That's the kind of thing that you should have memorized in your head. So our start point, there was no phase shift, no shift left, I'm sorry, yes there was. Phase shift left pi. So instead of starting at this 0, 0, I'm going to take that starting point, I'm going to shift it left pi. So this is my first critical point, right? Now, where would it end? If the period is 2 pi, I need to go 2 pi from this starting point. So you might want to do like, you're starting at negative pi, add the period to it, and that will get you your ending point. So this is my starting point. I'm adding my period to it, and then that gets you your ending point of the cycle. So my ending point of the cycle is going to be at pi. What happens there? We're on that middle line again. Okay, so this is my one cycle. I'm now going to stay in between these 2 points. This is the beginning, this is the end, right? This is the beginning, this is the end. I forget that when I'm pointing, you can't see that. So then we're going to find the midpoint, right? The midpoint is on that middle line. So the midpoint is right here. Find the 2 smaller midpoints. The first midpoint always goes up, right? It's going to go up to the amplitude. So up 1, and then down 1 space for the second one. Now, this first dot always goes up unless there's a reflection over the x-axis. If there's a reflection over the x-axis, then that first point would go down and the second midpoint would go up. Okay, so these are my 5 critical points. Highlight them with your highlighter or colored pencil, and then you're going to copy and paste. So just continue the pattern, right? However you do this is fine. You can go like middle, down, middle, up, middle, down, middle, and then it would be an up, right? You can do that. And there you go. Let's try another one. All right, I'm going to do one more that has a vertical shift, and then I'll continue and do 2 more examples. But after this one, I would say if you feel good, you can shut the video off and go do your rest of your assignment. But this one is important because it has a vertical shift. And actually, you know what? The next one's kind of important because it has a horizontal compression. It changes the period. So hang around for one more. Okay, so amplitude is 3. Period is 2 pi because there's no b value there. Transformation is a vertical stretch by a factor of 3. Okay, I'm going to not write that. And then this minus 1 is a vertical shift down 1. Okay, so this is where when you have a vertical shift, you need a new middle line. So I'm going to draw that. I'm just moving that x-axis down 1. And now this blue dashed line, pretend that's your new x-axis, right? If you can really pretend this is the new x-axis, that would be great. Okay, so sine. How does sine start? Sine starts typically at 0, 0. We don't have a phase shift left or right, so we are going to stay at 0. And this is my new 0, 0 right here. Pretend this is the new x-axis, okay? Where does sine end? Sine ends at its period, so we're going to end over here at 2 pi. The midpoint is also at the middle. The smaller midpoints go up and down. The first one goes up, and it's going to go up 3. So 3 from that middle line. 1, 2, 3. So 3 from the middle line, not 3 from the original x-axis, 3 from our new x-axis. And then the smaller midpoint on the other side goes down 1, 2, 3. Yes, it goes off the graph a little bit. These are your 5 critical points. And then we're going to copy and paste. So down, up. This one's down. This one's up. All right, and general rule for me, just fit whatever you can on the graph paper. But those 5 critical points should be highlighted. And there you go. All right, stick around for this one more example. So y equals cosine of 4x. So amplitude is 1. There's no number out in front. Period. Period is going to be 2 pi divided by absolute value of 4, which is 4. So the period, I'm going to simplify this, is pi over 2. So that means from the start of the cycle to the end of the cycle, it's only covering a distance of pi over 2. Transformation here would be a horizontal compression by a factor of 1/4. Okay. Okay, what does cosine look like? Let's go to the graph. Cosine starts up, right? Cosine starts up. There's no phase shift here, so we're going to start at 0. I don't need a new middle line because there's no vertical shift. So I'm going to go up to the amplitude number, which is 1. Okay, what does cosine do? Where does it end? It ends up. Now normally this is 2 pi. This time I'm only going pi over 2. So my starting point was at 0. I'm going to add the period to that, and that tells me where I end, right? Remember, this is start, add the period to it, and that will tell me where I end. So I'm going to end at pi over 2, and I end up. So this is one cycle. Everything is going to fit between these 2 points, okay? So find the midpoint. The midpoint is pi over 4. You don't have to label that. I'm just mentioning it. So what happens at the midpoint? At the midpoint, we go down the amplitude distance. So we're going to go down 1 from the middle line. And then at the 2 smaller midpoints, what happens? We're on our middle line. So there's no marks there. I'm just going to estimate. These are my 5 critical points. I'm going to highlight them. You should do the same. And then I would copy, paste, copy, paste, copy, paste, right? Sometimes people will just kind of do this, find a pattern. It's like every other. On the bottom, it's like filling those gaps, every other. Yes, it's a lot. You'll survive. And then on the middle, this is where people say, do I have to plot all those? I would say like do a few and then just don't get sloppy. Right, so that should be hitting the midpoint every time. There you go. So there you go. We've had a lot of cycles on this one. All right, so I'm going to do one extra example. You really can stop the video here if you want to. And actually, I should have been using larger graph paper for this example. So my mistake. Okay, so this example, we're going to do 3 sine of 1/2 x. So amplitude is 3. The period is 2 pi divided by the b value, which is 1/2. Do a little keep, change, flip. Your period is 4 pi. Transformation, there's a vertical stretch by a factor of 3. There is a horizontal stretch. So this is why I really wanted big graph paper, and this is by a factor of 2 for the horizontal stretch. So how does sine start? Sine starts at 0. Where does it end? It ends from 0 to the distance of 4 pi. So we're going to go all the way here to 4 pi. That's going to be our ending point of one cycle. So everything's going to fit between these 2 points. So that was the end. The midpoint is also on the middle line, so the midpoint would be at 2 pi. The two smaller midpoints go up and down. So the first midpoint would be at pi. We're going to go up to 3. The second midpoint would be at 3 pi. And we're going to go down to 3 from that middle line. That's your one cycle. I'm going to highlight my 5 critical points. You should do the same. And then I'm going to copy and paste. We're going at intervals of pi. So at negative pi, it would go down. And you're just going to fill the graph paper with whatever you can fit. Okay? If you have questions, let me know. I'm around. Just shoot me an email or add it to the class document. And I'll see you on Google Meet, hopefully, for extra help. All right. Bye, guys.